Listen. So for the oscillations, we required one important term, and that is periodic motion. Periodic motion. What is the periodic motion? Periodic motion is nothing but a particle or a body, moves to and fro about the mean position at regular intervals of time. A particle or a body moves to and fro about a mean position, at regular intervals of time, and that is known as periodic motion. So listen, what is the meaning of that? This is the mean position, O, mean position, that is O, and this moves to and fro, like this, towards as well as backwards, to and fro about the mean position at how much time? At regular intervals of time. Nothing but if a particle started from O, this O itself is called as mean position, starting point. Okay, so from this point it travels some distance, for example in half second. In the same half second it comes back and reaches to the mean position, and again moves in the opposite direction, travels the same distance, and that is half second only, and again come back to the mean position within the same half second. So moving towards half second and coming backwards again half second, and again moving backwards half second, and again moving to the same point, that is nothing but mean position again in half second. And this type of motion is known as periodic motion. So now here in the lesson oscillations, we required one important term, that is simple harmonic motion. Simple harmonic motion. What is the simple harmonic motion? The simple harmonic motion is nothing but it has to taken two different and very important conditions. And those two very important conditions are, the first one is the motion should be periodic. Just now I said, what about the periodic? What is the periodic? Periodic motion is nothing but the body or particle should travel about the mean position to and fro at regular intervals of time. So from mean position to whatever the distance it traveled and whatever the time is taken, the same time has to be considered by the same particle to travel the same distance in the opposite direction, and that is known as periodic motion. Are you getting now? So the motion should be periodic. This is the first point. And second point is nothing but the acceleration of the particle is directly proportional to the displacement of the particle. A is the acceleration and x is the displacement. Acceleration of the particle is directly proportional to the displacement of the particle. Then how these two directions are? This here one more important topic is the direction. The direction of acceleration, the direction of displacement, and both are must be in opposite direction. That's why here we consider minus. A proportional to minus x. A represents what? Acceleration. X represents what? Displacement. A represents acceleration, x represents displacement. Okay, acceleration of the particle is directly proportional to the displacement of the particle, but acting in opposite direction. When any particle or any body motion satisfies these two conditions. The motion of a particle or the motion of the body satisfies these two conditions. These two conditions. Then we used to say that the motion of the body or particle is in simple harmonic motion, that we are representing as S H M. S H M. Okay, now, in the simple harmonic motion, there are two types again. There are two types, and those two types here we are taking it as the first one is a linear simple harmonic motion. What is the first one here? Linear simple harmonic motion. What is the second one? Angular simple harmonic motion. One is the linear simple harmonic motion, the other one is the angular simple harmonic motion. Okay, getting? Okay, now see, the linear simple harmonic motion and angular simple harmonic motion, these are the two types of SHM. At first I am taking the linear simple harmonic motion. At first I am taking this one, linear simple harmonic motion. What is the condition of linear simple harmonic motion? So at first, for the explanation of SHM, whatever the condition I used to consider, acceleration is directly proportional to the displacement. Here acceleration is nothing but linear acceleration. Acceleration is nothing but linear acceleration. X is nothing but displacement. That itself is called as linear displacement. Linear acceleration, linear displacement. So that itself is the condition of the linear simple harmonic motion. A proportional to minus x, then A is equal to minus omega square x. A proportional to minus x, then A is equal to what? Minus omega square x. Minus omega square x. Okay, now, and this is the condition of linear simple harmonic motion. Linear simple harmonic motion, right? And now, next one. How come you consider the acceleration? Acceleration we are taking in such a way that if the displacement can be differentiate, then you will get a velocity. So dx by dt. If the displacement can be differentiate, x can be differentiate, then you will get the velocity. This is the velocity. Again you differentiate second derivative, we call it as second derivative. If the displacement can be differentiate second time, then you will get the acceleration. The displacement first time, if you differentiate, you will get velocity. The velocity again you differentiate, nothing but second time differentiation. That's why d square x by dt square. The meaning of d square x by dt square is nothing but what? Acceleration. It means what? D square dt square. What it represents? The displacement is x. X can be differentiated two times. Then you will get the velocity acceleration. That is the meaning of that. If the x is the displacement, x can be differentiated two times. X can be differentiated two times. Then you will get the acceleration. That is the meaning of that. Okay, d square x by dt square is equal to minus omega square x. Now, if you take this minus omega square x this side, then that became as d square x by dt square, d square x by dt square plus minus take this side, that became as plus omega square x is equal to 0. And this is the condition of linear simple harmonic motion. D square x by dt square plus omega square x is equal to 0. Or you need to remember, or you can remember this also, a is equal to minus omega square x. Getting? Okay, very simple topic. There is no confusion. There is no confusion here. Once again, I'm repeating this linear simple harmonic motion. Linear simple harmonic motion means the body has to travel horizontally, along horizontally or vertically. So along the straight line, it has to travel. Then we used to consider the topic of linear simple harmonic motion. Linear, linear means translatory. So it has to travel along a straight line. That is the meaning of that. Okay, now once you consider the acceleration, acceleration is directly proportional to the displacement of the particle. Then how these two directions? The directions of these two are opposite. So we used to represent like acceleration of the particle is directly proportional to the displacement of the particle and acting in what it gives, minus gives opposite direction, acting in opposite direction. So simply we are taking it as a is equal to what, minus omega square x, minus omega square x. So here we are taking in such a way that that same formula we are rearranging as d square x by dt square, d square x by dt square plus omega square is equal to 0. Then what here omega represents? Omega nothing but here angular velocity of the particle. What's the omega? Omega is nothing but angular velocity of the particle. Okay, now I'm taking the another part that is angular simple harmonic motion. Angular simple harmonic motion. The word itself is very clear. The word itself is very clear. What's that? Angular. Angular. Angular means the body is in rotatory motion. So it means previously linear, and that's why we considered linear acceleration, linear displacement, A and X. Now those two are replaced with A, replaced with alpha. A represents linear acceleration. Alpha represents angular acceleration. What's the alpha? Angular acceleration. X, linear displacement. Linear displacement replaced with angular displacement, theta. A is the linear acceleration. This linear acceleration replaced with what? Alpha, angular acceleration. X, linear displacement replaced with angular displacement, theta. So the formula A is equal to minus omega square x. Already you know this. And this formula I am taking it as A replaced with what? Alpha is equal to minus omega square. X replaced with what? Theta. Alpha is equal to minus omega square theta. Alpha is equal to minus omega square theta. This is the representation of angular simple harmonic motion. Okay, now the same formula can be considered as previously we considered that the displacement can be differentiate two times, then you got the acceleration in the last topic, linear simple harmonic motion. Now in this topic it is very clear that the angular displacement theta, if you differentiate two times d square theta by dt square, previously we considered that d square x by dt square, x is the linear displacement, that x replaced with theta, just that only the modification here, d square theta by dt square proportional to or is equal to minus omega square theta. Now take this minus towards this side, d square theta by dt square plus omega square theta is equal to 0. This is the condition of another condition of angular simple harmonic motion. Either alpha is equal to minus omega square theta or d square theta by dt square plus omega square theta is equal to 0. So any one of these gives the condition of angular simple harmonic motion. Okay. Now, so the coming topic is very, very important. These are how come you represent equation, as well as waveforms also very, very important here. And if a particle is in linear simple harmonic motion, how come you represent in the form of a wave? How come you represent in the form of a wave? It means here you need to remember, concentrate properly, all of you. If you are considering a particle is moving from mean position, what is the equation of simple harmonic motion of that particle? If a particle is moving from extreme position, what is the meaning of extreme position? Extreme position means the particle reached the maximum displacement, and from there again it comes back. From there again it comes back. So where it reaches to consider the maximum displacement, that position is known as extreme position. That position is known as extreme position. So here I am representing like this. For example, this is the main position. From here, it travels in this direction, and this is positive x-axis, and this is nothing but we are taking it as plus a. The maximum displacement done by the particle is known as amplitude. So meanwhile, I'm taking the parameters of a particle which is in simple harmonic motion also. Where some parameters required, some physical quantities required to explain the motion of the particle. So those parameters here I'm taking. The first parameter here I'm considering as amplitude. Okay, what is the amplitude? The maximum displacement done by the particle is known as amplitude, maximum displacement. Nothing but more than that, it cannot travel, it cannot move more than that. So this is the point which we consider this is the maximum displacement, that we are treating it as plus a. And again, it comes back from plus a to mean position, moving towards maximum displacement, and again from there coming back to the mean position, and again from the mean position it is moving in the opposite direction like this, and this is the negative x-axis, and that's why here I am taking that minus a. So towards positive x-axis, it travels maximum displacement, and that maximum displacement we are treating it as plus a, and again comes back to the mean position, and then thereby here we are taking that comes back to the mean position, and from here again moving towards the negative x-axis, and that is minus a, and again moving to the mean position. So like this continuously it travels to and fro about the mean position. This O represents the mean position, plus a represents one end of the maximum displacement, and minus a represent another end of the maximum displacement. What we call it as amplitude. What we call it as amplitude. Are you getting? Okay. Now, see in this how we are representing in the form of wave equation. See, as we consider it as it travels along the x-axis with respect to the mean position, and that's why we are representing like this. If any particle is moving from mean position, the wave should be like this. This is called sine wave. This we call it as sine wave. Why we call it as sine wave? Why? It means whereas in case of sine wave, sine 0, 0, then 0, 30 degree, 60 degree, 45 degree, 60 degree, 90 degree. If you consider sine 90 is equal to what's the value? 1. Nothing but if 0 to 90 degree values increased, the numerical value of the sine value also increases from 0 to 1. Sine 0 to sine 90, if you increase 0 degree, 30 degree, 45 degree, 60 degree, 90 degree, then those values also increased from 0 to 1. And that's why it started from the origin. Sine 0, this is 0 degree, and this is 0 degree. Okay, and this is nothing but 90 degree. Exactly, we can set as 90 degree, pi by 2, pi by 2. And this is pi. This point we are representing it as pi. And this point here we are representing it as 3 pi by 2. And this point here we are representing it as 2 pi. Pi by 2, pi, 3 pi by 2, 2 pi. Like that we represent. Like that we represent. So just now I considered that 0 to 90, 0 to 1. This is the origin, 0. It reached to the maximum end. This is the maximum point. Maximum nothing but what is the value? 1. And again from sine 90 to sine 180, sine 90 to sine 180, 1 to 0, the value gradually decreases, and again 1 to again intercepts the x-axis, so became 0, and again increases towards the negative x-axis, minus value, and again became 0. Like that, 0 to maximum, maximum to 0, 0 to maximum, maximum to 0, 0 to another end maximum, and maximum to 0, 0 to maximum, maximum to 0, 0 to another end maximum, maximum to 0. They like this, we can represent the sine wave for the representation of a particle which is in simple harmonic motion, which travels from the mean position. Travels from the mean position. Are you getting? Okay. Now, next, in the same way, we can represent the cos wave. Once we consider the cos wave. Otherwise, if you, this is the positive extreme, we call it as positive extreme. The positive extreme. Positive extreme. It means what? And that is nothing but here we are taking the concept it as from mean position to positive extreme it traveled. For example, if a particle traveled from mean position to negative extreme like this, the wave is like this, mean position to negative extreme, 0 to maximum, maximum to 0. This is pi by 2, this is pi, 3 pi by 2, and this is nothing but 2 pi. This is nothing but 2 pi. So how come you represent this with the equation form? Y is equal to a sine omega t. If the particle moves from mean position to positive extreme position, take the equation y is equal to a sine omega t. Now here the particle moves from mean position to negative extreme. See the curve, negative extreme. This is the negative y-axis, no, negative extreme. Then we used to take it as y is equal to minus a sine omega t, and this is minus a, and this is plus a, and that's why this is called positive extreme. This is called positive extreme, and this is called negative extreme. So here, if any particle moves from mean position to the positive extreme, then take the formula y is equal to a sine omega t. If any particle moves from mean position to negative extreme, then we used to consider it as y is equal to minus a sine omega t. Okay, now fine. So now, if any particle started from the extreme position, just I'm giving the idea. I'm giving the idea to you. Extreme position. Nothing but the particle has to travel from maximum displacement like this. Like this curve is present, that is the meaning of that. The meaning of that is this is 0, pi by 2, and this is pi, 3 pi by 2, and this is 2 pi, 2 pi. So y is equal to a cos omega t. The equation is y is equal to a cos omega t. So this is the topic. We considered that the particles started from the extreme position, positive extreme position. We call it as positive extreme position. Okay, if the particles started from negative extreme position, how come you consider that? And this is the origin, negative extreme position, nothing but you consider from here. Like this. This is the concept related to the negative extreme position. This is the 0, pi by 2, pi, 3 pi by 2, and exactly this value is 2 pi. Here 2 pi we will get. Okay, this is 3 pi by 2 and this is 2 pi. And what is the equation for this? Y is equal to minus a cos omega t. What's the value, ma? Y is equal to minus a cos omega t. Minus a cos omega t. So like this we can consider, if the particle moves from positive extreme position, y is equal to a cos omega t. Then particle moves from negative extreme position, y is equal to minus a cos omega t. It means this is minus a, negative end, negative y-axis minus a. This is the positive y-axis. That's why this part is nothing but plus a, plus a. So like this, we can consider the negative as well as positive extreme positions. If the particle started from the mean position or extreme position, how come we considered? We can consider like this. Okay, and now see. Here, if the particle is travel from mean position to half the amplitude, mean position to half the amplitude. What is the mean position to half the amplitude? Mean position is nothing but 0. Half the amplitude. Amplitude is a. Half the amplitude, a by 2. How much time it takes? How much time it takes? So this is the mean position. Observe. Try to understand. One end of the extreme position is plus a. One end of the extreme position is plus a. Okay. And now, in this half the distance, a by 2. From 0 to a by 2. From 0 to a by 2. Travel. For traveling from 0 to a by 2, how much time taken by the particle? That our question. That is our question. So for that, as you know, the particle moved from the mean position, travels towards the positive extreme end, and that's why here I am taking that y is equal to a sine omega t, a sine omega t. Then y is equal to a sine. I need to consider another thing, that is omega. Omega is nothing but 2 pi by capital T. 2 pi by capital T. Capital T means time period. Time taken by the particle to complete one oscillation is known as time period. Y is equal to a sine 2 pi by capital T into small t. That is the omega value, 2 pi by capital T. Okay, now what is the y? Y is nothing but where it reached, a by 2. Where it reached here, a by 2. So a by 2, in the place y, I am taking it as a by 2, a sine of 2 pi by capital T into small t. A get cancelled. 1 by 2 is equal to sine 2 pi by capital T into small t. sine 2 pi by capital T into small t. In sine way, in the sine trigonometric function, when we will get 1 by 2? When we will get 1 by 2? Sine 30. Sine 30 is 1 by 2. Sine 30 means, how come you write it as pi by 6? Sine pi by 6. Pi means 180 by 6. Sine 30 is equal to sine of 2 pi by capital T into small t. Into small t. Now listen, both sides sine function is present, so I am removing that. Pi by 6 is equal to 2 pi by capital T into small t. Then pi get cancelled, pi cancelled, small t is equal to, take the cross multiplication, capital T by 2 also come to the cross multiplication as the denominator, 2 6 are 12. So in the time t is equal to capital T by 12 seconds, the particle reached from mean position to half the amplitude. Half the amplitude. So just blindly you remember this, y 0 to half the amplitude. What is the time? T by 12. Time is T by 12. Okay, and then in the same way here, y is equal to a by 2 to a by 2 to a, and what is the time? T by 6. T by 6, and y is equal to 0 to, this is very very important, y is equal to 0 to a by root 2. A by root 2, 1 by root 2 times of the amplitude. For traveling this distance, the time taken by the particle is t is equal to t by 8. T is equal to, what's the value? T by 8. And again from a by root 2 to 0 also, a by root 2, y is equal to a by root 2 to a amplitude. And what is the time? Same time it takes, t by 8. Same time it takes, t by 8. These four you need to remember. Y is equal to mean position to a by 2, t by 12, a by 2 to a, t by 6, and again mean position to 1 by root 2 times of the amplitude, t by 8, and again 1 by root 2 times of the amplitude to amplitude, that is again t by 8. Again t by 8. Okay. Next. See here, we need to calculate the next one is velocity of the particle. Velocity of particle. How come you consider the velocity of particle? Listen. So velocity of particle is nothing but, here we can consider it as v is equal to, velocity is nothing but v. As you know, earlier I said to you that the rate of change in displacement is called velocity. The rate of change in displacement is called velocity. So v is equal to, what's the value? dy by dt. V is equal to, what's the value, ma? V is equal to dy by dt. So here, that is nothing but d by dt of y is nothing but what? A sine omega t. Y is equal to, what's the value? A sine omega t. Okay, then v is equal to, take out the a, d by dt of sine omega t. If you differentiate that, differentiation of sine is cos omega t, and again you need to differentiate omega t. Why? Because in the omega t we have the time as a function. Okay, so if you, the differentiation of sine is cos. At first we differentiate the trigonometric function. After that we are differentiating the value in the trigonometric function omega t. Now v is equal to, if you differentiate d by dt of omega t, omega take out as a constant, d by dt of t is equal to 1. So that omega I am combining with a omega cos omega t. and this is the formula of velocity of a particle which is in simple harmonic motion, a omega cos omega t, if the particle moves from the mean position. The particle moves from the mean position. Okay, so now the same value here we are representing it as v is equal to omega root over a square minus y square. This is also another formula for doing the numericals, for calculating the velocity of particle which is in simple harmonic motion, consisting of two formulae. One is v is equal to a omega cos omega t. The another one is, from this only we considered, and v is equal to omega root over a square minus y square. Okay, now at mean position as well as extreme position, what about the velocities of the particular simple harmonic oscillator? When I'm using the word simple harmonic oscillator, the word itself is very clear indication that the particle is in simple harmonic motion. So instead of saying all these terminologies, simply I'm using a word that is simple harmonic oscillator. Are you getting? Now, at mean position, how come we consider that? Mean position is nothing but what's the value? Y is equal to 0. Remember this. Mean position is nothing but that itself is the starting point. Starting point means v 0 origin. So y is equal to 0. Now v is equal to omega root over a square minus y means 0 square, a square minus 0 square, a square, under square root it is. So that's why that is v max. So we call it as v max, that is equal to omega a. Very, 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 very important. V max. The velocity at the mean position is maximum. V max is equal to omega a. And this itself we are writing it also like 2 pi by capital T into a. Omega is nothing but 2 pi by capital T into a. So this is at mean position. Velocity of the particle, simple harmonic oscillator at mean position is V max is equal to omega a. At extreme position, y is equal to a. At extreme position, y is equal to a. It means what? V is equal to omega root over a square minus y replaced with a, again a square. A square minus a square 0. That is nothing but v min. V min is equal to what's the value? 0. At extreme position, the velocity of the particle is 0. Velocity of the particle is 0. These two you need to remember again. At mean position, the velocity is maximum, that is omega a. At extreme position, the velocity is minimum and the value is 0. Minimum means 0. Okay. The next one is acceleration of a particle. Acceleration. Acceleration of a particle. How come you consider the acceleration of a particle? Previously, I said to you that if the displacement one time, if you differentiate, you will get the velocity. Again, if you differentiate the velocity, you will get acceleration. It means what? The acceleration here, we are taking it as acceleration is equal to A is equal to dv by dt. A is equal to dv by dt. A is equal to d by dt of what we get as velocity. What we got as velocity. So velocity is equal to how come you consider that? A omega cos omega t. V is equal to how come you consider that? A omega cos omega t. Okay, so this is the formula of velocity. Now I am taking that a omega cos omega t. Then a is equal to a amplitude, omega is the angular frequency, both are constants, take out. Then d by dt of cos omega t, d by dt of cos omega t. Differentiation of cos minus sine. Differentiation of cos is minus sine omega t, and again differentiate the omega t. Now take out the omega from the differentiation. D by dt of t remains, that value is equal to 1. So a is equal to minus, I'm writing in at first a omega, and here from here also again you will get one more omega into omega square sine omega t. Sine omega t. A is equal to minus a omega square sine omega t. Then from this a is equal to minus omega square. This a sine omega t I am writing. Just rearrange the term. A and sine omega t, both I can combine, and I am writing that. Both I am combining and writing that. So what is that? A sine omega t. A sine omega t, nothing but what? Y. What is the a sine omega t? Y. Y. So now I'm replacing a is equal to minus omega square a sine omega t as y. This is the formula of acceleration of the simple harmonic oscillator. If a particle is in simple harmonic motion, the acceleration of the particle is a is equal to minus omega square y. A is equal to minus omega square y. So at mean position as well as extreme position, what about those values? Now we can consider at mean position. If I say mean position, immediately you will get the concept as y is equal to 0. What do you need to get? Y equal to 0. If you take y equal to 0, then entire part equal to 0. And then you are taking it as a min. Once you got the value as 0, then that is called minimum acceleration. Where the velocity is maximum, there the acceleration is minimum. Where the velocity is maximum, there the acceleration is minimum. At mean position, velocity is maximum, but the acceleration is minimum. At extreme position, extreme position means, what is the meaning of that? Y is equal to a. So if y equal to a, then you get it as y is equal to minus omega square a. This itself is called as maximum, a max. At mean position, the acceleration is minimum, and whereas at the extreme position, the acceleration is maximum. So like this, we can consider the acceleration of the particle. Okay, now in 2019 NEET, one question is asked from this topic. Okay, now I am explaining that. So this can be asked in 2019 NEET. So question is nothing but during one complete oscillation, what is the meaning of complete oscillation? This is the origin. Complete oscillation I am explaining, just focus on that. That word is very, very important. From mean position, the body started and moved one end of the extreme position plus a, and again come back, and again come back, and again move to the another end of the extreme position, and again come back to the mean position. From where it started, again it reaches the same point at last. That is known as oscillation. From mean position to extreme position, one end O2 plus A. What is the total distance traveled? A. From extreme position to again mean position, again the same distance traveled, A plus A, that is 2A. And again from here, mean position to another end extreme position. What is the distance? A again. From extreme position to again the mean position, again the same distance. A plus A, 2A. So now in one oscillation, what is the total distance traveled by the particle? In one oscillation, what is the distance and what is the displacement? The distance traveled by the particle is 2A plus 2A, and that is equal to 4A. Distance is nothing but the total path covered by the body during the journey is known as distance. Already you know that. Okay, displacement. What is the displacement? Displacement is nothing but what is the initial point? Mean position. What is the final point? Again, it reaches the mean position at last. The path length between initial and final points is known as displacement. What is the position of the initial point? Origin. That is mean position. What is the position of the final point? At last, it reached the origin again. Origin again, mean position. So, what is the path length? From origin to origin, what is the path length? 0. And that's why the displacement is 0. The displacement is 0. Okay, distance is 4A and displacement is 0. Displacement is 0. Now, the question is, during one complete oscillation, just one complete oscillation means you need to remember all this topic. Then only you will get the idea for doing the numerical. Okay, in the sentence, every word is important. Every word is important. If you understand every word, then only you will get the idea to do the numerical. Okay, now, during one complete oscillation of a particle, the displacement becomes 0. The displacement becomes 0. The distance is 4A. Then what is the average speed and what is the average velocity? That we need to calculate. Average speed and average velocity. Average speed of the particle as well as average velocity of the particle. Speed is a scalar. So we need to consider the distance. Total distance by total time. Total distance by total time. Total distance. Distance is nothing but what's the value? 4A. Total time, capital T. The time taken to complete one oscillation is known as time period. Always time period represent with capital T. 4A by T means how come we consider that? 2 pi by omega. 2 pi by omega. Now we average. Average speed is equal to 4A. This omega goes to numerator by 2 pi. By 2 pi. Then 2 ones are 2 twos are. 2 ones are 2 twos are. 2 by pi. This A omega I am taking it as V max at the mean position, that is the maximum speed or maximum velocity. 2 by pi into V max. That is the answer for this average speed. Then average velocity. Average velocity. Average velocity means what? Total displacement by total time. Total displacement by total time. What is the displacement? What is the displacement? 0. 0 by anything equal to 0 by anything equal to 0. Average velocity is 0, whereas average speed is 2 by pi into V max. This problem they asked in 2019.